Hi, I'm Ernest Surveillance. My job, like yours, is to find and measure dangerous atmospheres. I guess you could call us detectives. And like detectives, we have special tools of the trade to help us track down our suspect. When that suspect is combustible gas, the instrument we use is the explosimeter indicator Model 2A. And that's the purpose of our meeting today, to learn how the instrument works and how to care for it. But first, let's find out a bit more about our suspect, combustible gases or vapors. To start, let's quickly review how combustion occurs. First, there must be fuel. Second, there must be oxygen to support combustion. And third, there must be heat, or a source of ignition. This is known as the fire triangle. But remove any one of the legs of the triangle and no combustion. The percentage of combustible gas in the air is important. Imagine for a moment an enclosed space, like a manhole, that's filled with fresh air. Gradually, a combustible gas like methane or natural gas leaks into the manhole, mixing with the fresh air. As the ratio of gas to air changes, our sample passes through three regions: lean, explosive, and rich. In the lean region, there isn't enough gas in the air to burn. On the other hand, the rich region has too much gas and not enough air. However, the explosive range has just the right combination of gas and air to form an explosive mixture. Let's look at the three ranges in another way. The green dots represent oxygen, and the red dots, combustible gas. If the source of ignition is removed from the lean and rich ranges, the mixture won't burn, because the matching pairs of oxygen and fuel molecules are too far apart. Quite simply, if a pair of molecules does ignite, they'll cool off before they reach the next pair. On the other hand, if a pair of molecules in the explosive range is ignited, they'll ignite another pair, which will ignite, and so on. It's a chain reaction. The explosive range starts at the lower explosive limit, or LEL, and ends at the upper explosive limit, or UEL. The limits vary for different gases. We should also mention that in some industries, these points are called the lower and upper flammable limits. Whatever you call them, though, they are the lowest and highest concentrations of combustibles in air that will burn. Okay, now that we know more about our suspect, combustible gas, let's find out how this instrument called an explosimeter indicator works. As the name suggests, it's designed to detect the presence of explosive or combustible gases in the air. It's based on the principle that a measurable amount of heat is released when a combustible gas or vapor is burned. Here, the combustible is burned on a coil of platinum wire. The increase in temperature changes the electrical resistance of the wire. This coil of wire is called a filament, and it's one leg of an electrical circuit known as a Wheatstone bridge. The other three legs are resistors whose resistances do not change. There's also a battery and a meter connected to the circuit. If there is no combustible in the sample to burn, the resistance of the filament doesn't change. Therefore, the resistance remains constant in all four legs of the bridge, and it's in balance. If there is combustible gas in the sample, it will burn on the filament. As a result, both the temperature and resistance of the filament rise. Because the resistance of the detector filament is higher than the other resistors, the bridge is out of balance. The degree to which the bridge is out of balance is proportional to the temperature change, and consequently the amount of combustible in the sample. As a result, the meter goes upscale. Still with me? Good. To this point, we've created an electrical circuit, the Wheatstone bridge. Now let's put it to practical use. First, enclose the detector filament in a sampling cell. Then add a pump to draw the sample into the cell. Finally, add a means of adjusting the measuring circuit to 0 and an on-off switch. The finished product, a bit simplified perhaps, is the explosimeter Model 2A. And here's how it works. The aspirator bulb draws the sample into the instrument. The sample passes through a cotton filter and a flashback arrestor before it arrives at the combustion chamber. There it passes over the detector filament. If there is a combustible in the sample, it will burn on the filament and the meter needle will rise. The sample leaves the instrument through another flashback arrestor and the outlet on the aspirator bulb. The flashback arrestors cool the burning sample so that it won't ignite any combustibles outside of the explosimeter indicator, either in the place tested or the area where you're standing. So much for theory. Now let's go through the sampling routine with the explosimeter indicator. There are 7 easy steps. 1. Lift the on-off locking bar of the rheostat knob and turn it a quarter turn to the right. This closes the battery circuit, so the needle may either move rapidly upscale and then return to a point below 0, or drop directly below 0. 2. Flush the instrument with fresh air to remove all traces of gases or vapors. 5 squeezes of the aspirator bulb should be enough. If you're using a sampling line, add 2 squeezes for each 10 feet of line. 3. Turn the rheostat knob to the right until the needle is at 0. Be careful not to move the needle above 0, because the excessive current can damage the detector filament. 4. Get the instrument and sampling line in position, and if necessary, readjust the meter pointer to 0 before sampling. 5. Now you're ready to sample. 5 squeezes of the bulb, plus 2 squeezes for each 10 feet of sampling line, should be enough to draw the sample through the instrument, but keep squeezing until you get the highest reading. The reading on the meter shows the concentration of combustible gases or vapors in the sample. The graduations on the meter represent the percent of the lower explosive limit. We'll talk more about meter readings in just a moment. 6. When you're finished sampling, flush the instrument with fresh air to remove all traces of gases and vapors. The 7th and the final step is to turn the instrument off. Turn the rheostat knob to the left until the arrow on the knob points to off. The locking bar will then drop into position in its slot. Sound easy? Well, it is. But there are some rules that you must follow when sampling. The most important thing you must remember is always keep your eyes on the meter. To show you why it's so important, let's see what happens when we add gas to fresh air. As gas is added, the needle goes upscale and stays there. If it reaches 100, the concentration is now at the lower explosive limit. If we keep adding gas, the mixture will pass through the explosive range and the upper explosive limit. If the concentration is above the UEL, the needle will drop. So if the needle moves first to the right and then to the left of the scale, it's an indication the sample is above the upper explosive limit. Now let's suppose you had taken your eyes from the meter when the needle went upscale and then dropped. When you did look, the meter read 50%. If this was an actual 50% LEL reading, you could safely ventilate the area. On the other hand, if the meter reading indicated that the concentration was actually above the UEL and you tried to ventilate the area, you would have to take extra safety precautions because fresh air will dilute the concentration back into the explosive range. If you haven't watched the meter carefully or aren't sure about the reading, remove the sampling line from the area and draw fresh air through the instrument. When you retest and the meter needle moves first to the right and then to the left of the scale, it's a genuine indication that the sample is above the upper explosive limit. Another situation that may occur with a sample in the rich range is that the needle will go upscale and come down to a point slightly above or slightly below 0. This depends on how well the gas in the sample conducts heat. Because gases conduct heat in different degrees, there may be a shift in the 0 even though there's no combustion. If this happens, don't assume the instrument 0 has drifted. Again, flush the instrument with clean air, re-zero, and retest. If the sample is in the rich range, the fresh air will cause the meter to go upscale and then back down to 0 as the combustibles displace the fresh air in the detector chamber. You'll notice that the meter scale is colored red from 60 to 100%. This means that gas concentrations in this range, regardless of the combustible, may be close to the explosive point, and some action should be taken. Do you know the level at which your company specifies that ventilation must begin, or that the area must be cleared and entry by workers prohibited? If you don't, check with your supervisor. To recap, if the meter needle goes upscale above 100% and stays there, the sample is probably in the flammable or explosive range. If the needle moves rapidly across the scale and returns to 0 or below, the concentration is above the UEL. There are several important cautions you should follow when sampling. If the concentration in the area is questionable, keep testing while work is in progress. It may change. For example, a petroleum storage tank might be considered safe until work begins. Stirring or handling the sludge on the bottom of the tank could put the area into the dangerous range in a hurry. Or tests at a kerosene storage tank during the cool morning hours would show almost no vapors at 75 degrees Fahrenheit. But as the sun heats the kerosene to its flash point of 125 degrees Fahrenheit, the liquid gives off enough vapors to make it a combustible mixture with air if there's a source of ignition. Now you see why many situations call for more than one test. The explosimeter Model 2A can't be used under all conditions. For example, silicon compounds and acid gases will poison the filament, and it won't respond accurately. So will gasoline vapors, unless a special filter is used. The explosimeter Model 2A should not be used in oxygen-rich atmospheres where there's more than 21% oxygen. And the Model 2A won't work in oxygen-deficient atmospheres either. Also, there are special models of the explosimeter indicator with heavy-duty flashback arresters to keep explosions of mixtures of oxygen and hydrogen, or oxygen and acetylene, within the combustion chamber. Further, if you try to test solvents with a high flash point and the temperature of the test area is higher than the temperature of the instrument, there may be some condensation of combustible vapors in the sampling line and flow system. As a result, the instrument may not show the true concentration. 2 final points. The instrument will not detect combustible mists or sprays, such as lubricating oil, or explosive dusts like grain or coal dust. And always remember that although your tests may show the atmosphere is safe from a flammability standpoint, it could still be toxic to workers in the area. Always check with your supervisor to see if this is a consideration. Routine maintenance of the explosimeter Model 2A isn't complicated. The only tools you'll need are a screwdriver, long-nosed pliers, crescent wrench, and pipe cleaners. The most common maintenance jobs involve the electrical system, replacing the batteries and detector filament, and the flow system, replacing the filter and flashback arresters. In addition, you'll have to check the calibration of the instrument. Let's start with the batteries. The position of the pointer on the rheostat knob is a good indicator of battery condition. When the instrument is properly balanced with fresh cells, the pointer will face the left side of the case. As the batteries wear out, the rheostat knob must be turned further to the right to adjust the meter to 0. If the meter needle remains below 0, and you can't bring it up to 0 even when the rheostat knob is turned to the extreme right side of the case, it's time to replace the batteries. To change the batteries, unscrew the 2 large screws on the bottom of the case. You'll note that the slots on the screws are extra large, so you can use a coin to open the case if batteries need to be replaced in the field and a screwdriver isn't handy. The explosimeter indicator uses 6 D-size flashlight batteries. They should be replaced with Burgess or Ever-Ready batteries only, in order to keep the factory mutual approval for use in hazardous atmospheres. Although other batteries will work, the approval is void, because only these 2 brands have been tested for use with the instrument. Remove the old batteries and replace them with 6 new cells with the positive or button side down. New batteries should normally give 8 to 12 hours of continuous service. Longer life may be expected with intermittent use. But there are two important reminders about batteries. First, when you replace batteries, you must replace all of them. There must be no partial replacement. Second, if the instrument is not going to be used for any length of time, the batteries must be removed. As you know, there really is no such thing as a leak-proof carbon battery. The replaceable detector filament is the heart of the explosimeter indicator. Its service life depends to a great deal on the sample concentrations. So when concentrations are above the 100% mark on the scale, it's best to stop sampling and flush the instrument with fresh air to prolong the life of the filament. If the meter needle moves to the extreme right of the scale, stays there, and can't be adjusted to zero, usually the filament is burned out. To replace the filament, remove the 3 screws that hold the top cover in place. You'll find a spare detector filament is stored in the case. Remove the 2 green wires from the terminals on the top of the detector filament and unscrew the detector filament. Make sure that the new filament is screwed firmly into the chamber and that the gasket is clean and properly seated. Reconnect the 2 green lead wires firmly. Be sure that the terminal lugs and wires do not touch each other. And remember to replace the spare filament inside the case as soon as possible. Another replaceable component in the electrical system is the ballast lamp. Its job is to keep the circuit stable. The lamp should last the life of the instrument. However, if it does burn out, the meter needle will go downscale and stay there, despite attempts to adjust the zero control. The lamp must be replaced by another ballast lamp. These units are made specially for MSA, and a commercially made lamp must not be substituted. Finally, if the meter needle remains either upscale or downscale, and replacement of the filament or ballast lamp fails to correct the situation, one of the other arms of the Wheatstone bridge has failed. If this happens, the instrument must be replaced or returned to MSA for repairs. The flow system plays an important role in the operation of the explosimeter indicator, and it should be checked regularly. To check for leaks, close the inlet with one finger, then squeeze the aspirator bulb. Quickly seal the outlet of the aspirator bulb. With both fingers in place, the bulb should stay deflated. If it fills in less than 1 second, there's a leak in the flow system. To check the aspirator bulb exhaust for leakage, close the inlet of the instrument with one finger and squeeze the bulb, but don't seal off the outlet. It should take more than 5 or 6 seconds for the bulb to inflate completely. After you check for leaks, check the flow through the instrument. Squeeze the aspirator bulb, but this time don't block either the inlet or the exhaust. The bulb should fill completely in 1 to 2 seconds. The instrument has a replaceable cotton filter to remove smoke, dust, or moisture from the sample. The filter should be replaced regularly. If the filter gets wet, it should be replaced immediately. The explosimeter indicator must never be used without a filter. The filter is replaced by unscrewing the sample inlet coupling. Remove the filter and clean the chamber with a pipe cleaner or dry cloth and install a new filter. If this fails to restore the flow, try the flow regulating orifice in the aspirator bulb coupling. Remove the rubber tubing connection to the bulb, then unscrew the orifice. If it is clogged, clean it by pushing a fine wire through the opening. The final flow system components that may occasionally become clogged are the flashback arresters. Because they are important and relatively inexpensive, the arrestor should be replaced, not cleaned. However, if you can't get a replacement immediately, they can be washed in water and dried thoroughly. Never clean them with solvents. Remember, the explosimeter indicator must never be used without the flashback arresters, because they prevent the combustion that may occur in the instrument from reaching the hazardous atmosphere or the area where you're standing. To expose the inlet flashback arrestor, remove the detector filament and baffle plate. To expose the outlet flashback arrestor, remove the aspirator bulb coupling. Using long nose pliers, pull the cotter pin on which the arrestor is mounted. This may be difficult if excessive moisture in the sampling system has corroded the screen. Be sure the replacement arrestors fit snugly before reassembling the instrument. Other adjustments to the explosimeter indicator include the mechanical zero setting. If the meter needle does not rest on zero with the instrument turned off, it can be reset by turning the screw on the meter face. If the instrument hasn't been used for a while, or if samples have been taken in severely corrosive atmospheres, the contacts of the rheostat may become tarnished. The instrument's response will be erratic. To correct this, remove the batteries and turn the operating controls back and forth a number of times to clean the contact points. The final step in the explosimeter indicator maintenance procedure is a check of the calibration of the instrument. A calibration check should be performed at least weekly, although we prefer that the instrument be checked each day before sampling. In addition, any time you feel the instrument isn't working properly, check the calibration. The response of the explosimeter Model 2A is factory set using pentane as the calibration gas. This means the instrument will generally give a reading on the high or safe side when testing most other combustibles. The calibration may be checked in the field with a portable test kit or check kit containing a known concentration of methane in air. The first step in the calibration check process is to zero the instrument. If you're using the calibration test kit, connect the bladder assembly to the inlet fitting of the instrument. Insert the needle of the aerosol can of calibrating gas into the tubing, not the bladder, and press the button to inflate the bladder. Squeeze the aspirator bulb to draw the calibrating gas from the bladder into the instrument. Compare the upscale meter reading with the response curve for the explosimeter Model 2A furnished with the test kit. To use the Model R calibration check kit, zero the instrument, then connect the adapter hose from the cylinder of calibration gas to the inlet of the instrument. When you open the flow control valve, calibration gas enters the instrument. You don't have to use the aspirator bulb. When the meter reading stabilizes, compare it to the response scales furnished with the kit. If the instrument doesn't read within the acceptable range, replace the detector filament. Before we finish, you should be aware of several accessories for the explosimeter indicator. There's a hollow probe tube for sampling bar holes and manholes, and a solid probe rod for testing tanks that may contain liquids. When you're using probes to test in areas where conditions are unknown, a line trap like this may be used. Any liquid that's accidentally drawn into the sampling line will first appear in the bowl of the trap. Then you can stop sampling before the liquid is drawn into the instrument and causes damage. If leaded gasoline vapors are present, an inhibitor filter must be used to protect the filament from lead deposits. A charcoal filter in a cartridge holder absorbs organic vapors and helps distinguish between gases in the sample and vapors that may cause condensation in the sampling system. In this mini seminar, we've covered a lot of ground in a short time. So before you use the explosimeter indicator, take some time to carefully read the instructions that come with the instrument. And be sure to follow the instructions to the letter. This instrument must be used and maintained properly in order to do its job. And speaking of jobs, it's about time for us to get back on the trail of those suspects, combustible gases and vapors. This is Earnest Surveillance saying good luck and keep your eye on the meter.